All right, this is a video refreshing some parts of circles as well as introducing arcs of a circle and central angles. So just a couple of things, and feel free to pause your screen and write down some notes. You also might have been provided these by your teacher. The Just a couple of things about circles, a quick refresher. Circles is the set of all points in a plane equidistant from a fixed point called the center in that plane. So maybe you've thought about it before, but just to make sure, the reason a circle is round is because every single point that's on a circle is equidistant from that center point. So that equidistance is the thing that makes it round, and that equidistance is called the radius. So a lot of times we think about the diameter as being super important because it's the distance all the way across a circle. But really, it's the radius that dictates the difference between each type of circle that you see because the radius determines the size of that circle. If two circles are the same, it will be because they have the same radius. So the radius is super important. And again, that's the equidistance from any point on the circle to the center of the circle. Keep in mind that the center of the circle is not actually on the circle, it's in the center of the circle or on the inside interior. So the diameter is two of those radii together because you have to get to the center and then from the center to the other side. So the diameter is two times the radius. Again, a quick refresher. Something we'll talk about in another lesson are chords, and those are line segments that are in the interior of a circle whose endpoints are actually points on the circle. So there's a couple of examples there, like a diameter would be a chord, but not every chord has to be a diameter. It just has endpoints on the circle. All right, so we're going to move on and get specific now into what an arc of a circle is. All right, so here we go. And again, at any point, feel free to pause your screen and copy down whatever information is on my screen that you don't necessarily have on yours. I do want to pull your attention right to this definition over here to the right for arc. An arc is a piece of a circle. Another way to think about that, a way that I like to think about that, is an arc is to a circle as a segment is to a line. So an arc is a piece of a circle. So it's not the whole circle, it's not the full 360 degrees all the way around, it's just a section or a part of that 360 degrees. So if you look at my little picture here, from A to D, or from A to B, or from B to D, or from A all the way around to B, all of those are arcs. They're small pieces of the entire circle. All of those arcs together around the outside add up to the full 360 degrees of a circle. That's their measurements. And that's kind of what this is talking about with the sum of non-overlapping central angles equals 360 degrees. Notice that none of the arcs that I was just talking about included the letter C. C is the center of the circle, and it's on the interior of the circle. Arcs are the circle, so they have to be points on the circle. C is in the inside, so not actually on the circle. All right, so a couple of specific things with this. A minor arc is a smaller arc or an arc that's measure is less than 180 degrees. So for instance, arc A directly to B, arc AB would be a minor arc. If I went from A to the left past D all the way around the B, so arc ADB, that would be a major arc or an arc whose measure is larger than 180. Now, some of you might be thinking, well, what's so special about 180? Well, remember, if a full circle is 360 degrees, 180 is half of that. So a semicircle is really kind of your guide. So a semicircle is an arc whose measure is 180 degrees. A semicircle is half of a circle. So you would see the diameter using that semicircle to make half of a circle there. Adjacent arcs are arcs that share an endpoint. So for instance, in this case, arc AD and arc BD would be adjacent arcs. Arc DA and arc AB would be adjacent arcs. So arcs that share an endpoint. Concentric circles, so this is not really talking about arcs, but just some vocabulary to get straight. Concentric circles are circles with the same center. So you see my makeshift picture over here to the right. So you see all three of those circles have the same center. They're not the same circle, they're not congruent, but they all share the same center. Congruent circles, I said this earlier, congruent circles are circles with the same radius. So both of their distances from the outside to the center are the same. That's what makes two circles congruent. Notice that word radii, that's the plural of radius. All right, so again, pause if you need to write down any of these definitions. I'm going to focus on central angles and combine that with what we've talked about with arcs. Here we go. All right, so angles, central angles specifically, are angles whose vertex is at the center of a circle. So in this example right here, angle ACB is a central angle. Angle ACB, which is this angle right here, that is a central angle. Now, a central angle has a direct relationship to its corresponding arc. In this case, the arc that goes with that central angle ACB is this minor arc AB. Now, when I say goes with, it's in the interior of the angle. So you could see that piece of the circle is trapped between these two sides of our central angle. So that angle and that arc have a direct relationship. When I say they have a direct relationship, it is this right here. Arc measure equals central angle measure. And that's my symbol for angle. Feel free to write the word angle out if you'd like. So if I told you that the measure of this angle right here was, say, 80 degrees, then this arc right here would have to also be 80 degrees because central angle measure and arc measure are the exact same thing. Well, let's look kind of the outside of what we're talking about, or the other side of what we're talking about. So what about this angle right here? Well, that angle right there is the same measure as this arc that's highlighted. Well, if this green arc is 80 degrees, then this highlighted portion would be the total 360 of the circle minus the 80 of the arc that we already know. So if you do that subtraction, you get 280 degrees. So that means this big arc back here would be 280 degrees because 80 plus 280 is going to be 360. And if that arc is 280, then this angle where I have this red, this huge angle here, that would be 280 degrees as well. Now, some of you guys might be thinking, well, you're not supposed to have angles bigger than 180. In circles, we can have that because the max is 360 as opposed to a maximum of 180 in a line or a line segment. So 280 degrees is what my central angle in this case would be. Again, it's really important to say that the central angle measure and the arc measure are the same. Let's do an example of how all this is going to work together. Real quick, just for vocabulary purposes, I would like to do some naming of these minor arcs and major arcs. So, for instance, we said earlier, and it's worth writing down, arc AB would be a minor arc. Now, I think if you're really paying attention, you're noticing that there's two different ways that I could go from A to B. When I talk about an arc measure, it's the shortest distance from point to point. So if I say AB, it's the shortest distance from A to B. If I want to go from A the long way to B, so to the left, I'm going to have to include that letter D so that the reader knows that I went to the left as opposed to the right from A. So a major arc bigger than 180 would be like arc ADB. Now, we're never going to use more than 3 letters, but that third letter really helps you know which direction you had to go from A. Now, a semicircle would include a diameter. So if I went ahead and I just move this radius all the way across and I made a new point here, call it E, then we could say that arc ADE DE is a semicircle because it's half of a circle. All right, so again, feel free to pause your screen and write down any of that. Adjacent arcs, just a real quick example, that's arcs that share an endpoint. So like arc AB and arc AD would be adjacent arcs because they both share that point A. Okay? All right, so that's some vocabulary stuff for you there with naming some parts. Now we're going to see if we could put all this together. All right, here we go. Let's do this example here together. All right. What I want to do is I'm going to solve for both x and y. All right. Well, I could see that I've got a diameter here. So that means I can think about that as two semicircles or adding up to 180 degrees. Well, if this arc right here is 130, then that means I could just do 180 minus 130 to figure out what this arc right here is. Well, 180 minus 130 is 50. So this arc is 50 degrees. Well, this x right here goes with this angle, this central angle right here. So central angle and arc measure must be the exact same thing. So x is equal to the arc measure of 50 degrees. So we've already figured out half the problem. That's really good. Remember, central angle measure and arc measure are the exact same thing. Now we've got 3y to worry about. Well, I've got this right angle symbol here. So that tells me that that angle is 90, which immediately is going to tell me that this arc over here is also 90 degrees. And these two arcs with 3y and 90, 3y plus 90 should be 180 because that's the other half of the circle or the other semicircle. So if I solve here, subtract 90 from both sides, I've got 3y is equal to 90, divide both sides by 3 in order to get y by itself. Y is equal to 30. So now I've solved for both x and y, and I am completed with this problem. So keep in mind, just as a refresher, central angle measure and arc measure are the exact same thing. Central angle's vertex is at the center of the circle. All the arcs of a circle add up to 360. You have minor arcs that are less than 180, major arcs that are greater than 180, and semicircles that are equal to 180. All right, good luck.